Good evening. Am I audible, Safullah? Safullah?
Yes, sir.
Just tell me the last topic, what we did in last class.
We finish ascent formula, capillary tube.
Okay, that is a revision on fluid. Okay.
Yes, sir.
Tell me, we have completed wave and oscillation on revision.
Yes, oscillation waves are completed.
Okay. And tomorrow, you'll have tests on oscillation and wave. Okay. So just prepare for that
So I
also.
think wave revision is not given.
Okay, so let me finish with the fluid, then we'll start with wave. Okay.
Okay, sir.
So in last class, we had completed up to hydrostatic part of fluid. Next is in hydrodynamics. In hydrodynamics. You'll be asked to define suppose Reynolds number. Next, to define difference between streamline flow and suppose turbulent flow. And suppose if you're asked to define Reynolds number on the basis of different types of flow. First, tell me what do you mean by Reynolds number, Safullah? Any idea what do you mean by Reynolds number? Suppose liquid having some critical velocity so that flow is streamlined will depending upon three factors, that is density of liquid, diameter of tube in which liquid is flowing, and next is coefficient of viscosity of liquid. So on rearranging, you will get Reynolds number is equals to rho Vd divided by eta. It may be written in the form of rate of flow of liquid. So it will be 4 times rho into Q divided by pi d eta, where Q is called rate of flow of liquid. It may also be expressed in terms of inertial force by viscous force. Now, using this expression, you may calculate according to different flow of liquid. There will be number assigned with them. If it is less than 1,000, that will be termed as streamline flow. If it is more than 1,000 and less than 2,000, that will be laminar flow. And if it is in between 2,000 and 3,000, that will be unstable between turbulent and laminar. And if it is more than 3,000, that will be turbulent. Is it clear? Next, suppose if you have to define streamline, you will say we have tube in which non-viscous, incompressible liquid and irrotational is flowing, so that velocity of each layer of liquid will be constant at a given instant. That is called streamline flow. Ideally, it is not possible. That's why streamline flow is also called ideal flow. Safullah, any doubt?
Yes, as you said some kind of values, right? If this is lesser or greater than, can you say it again?
If Reynolds number is less than 1000, then it will be streamline. If it lies in between 2000 and 1000, that will be laminar. If it is in between 2000 and 3000, then it will be unstable between laminar and turbulent. If Reynolds number is greater than 3000, then it will be turbulent. Safallah, is it clear?
Yes, sir.
So this is streamline flow, for which liquid will be non-viscous, incompressible, and it will be irrotational. So that velocity of liquid at any instant or velocity of each layer will be same. Velocity of each layer at a given instant will be same. That is streamline. In case of laminar flow, suppose this is tube, so there will be viscous force in between layer of liquid. So centralmost liquid will be moving with maximum velocity, and as you move towards end, viscosity increases, so velocity of layer of liquid decreases. So flow of liquid will be like this. So this is called laminar flow. In case of turbulent, suppose we have irregular velocity of each layer of liquid. So due to irregularity in velocity of layer of liquid, there will be space created just after it, like this. Hence, this flow of liquid gets spiraled at that space, and this is called eddies formation. So if there is formation of eddies in a particular flow of liquid, then it's called turbulent flow. So mainly we have these three different types of flow of liquid on the basis of these different characteristics. So Fulla, any doubt?
No, sir.
Next is you will be asked to define Stokes law.
Sir, can you go up?
Just 1 minute. Yes.
Yes, sir.
Next is Stokes Law. Suppose a body is projected in viscous medium. So opposing force experienced by it due to viscous medium is F viscous equals to 6 pi eta r times V. This particular part is constant, so may call it as B times velocity. And since this particular force is opposing in nature, so it will have some negative sign with it. This B is called damping factor. Similarly, if you have to define viscous force between layer of liquid, defined by Newton's law of viscosity. According to this, viscous force between layer of liquid, it will be area eta dV by dy. Eta is coefficient of viscosity, A is area of liquid or film, dV is change in velocity, and dy is its width. Suppose this is layer of liquid and this is adjacent layer of liquid to it. Let's say this having velocity v, so this must be moving with some velocity v plus dv. So there is change in its width, let's say dy. So we may define each layer will tend to oppose its neighboring layer by a force which is called viscous force, which may depend upon this. Safrullah, is it clear? So this viscous force is between layer of liquid and this viscous force is acting on object projected in viscous medium. Experienced by body projected in viscous medium. Next is you'll be asked to define
In Newton's law, can you explain the diagram again?
Let's say this is a layer of liquid and this is adjacent layer of liquid. So according to Newton, flow of liquid will be always in layer by layer structure. This is one layer, this is adjacent to it and further adjacent to it and so on. Each layer will tend to oppose its neighboring layer by a force which is called viscous force, which is proportional to area of liquid or film and which is also proportional to velocity gradient. Velocity gradient is velocity change with respect to width or length. Is it clear?
Yes, sir.
So Newton's defined viscous force between layer of liquid, and according to Stokes, it is experienced by a body projected in that viscous medium. So both are viscous force, but when different body and layer of liquid. Next is terminal velocity. What do you mean by terminal velocity? Suppose this is any object which is dropped or projected in any viscous medium. So initially it will tend to accelerate due to weight experienced by it. But after some time, at a particular depth, let's say this, a force will be acting downward due to its weight, which is mass times gravity. Upward direction, viscous force, and upward direction, buoyant force. So net force acting on this part will be zero. So just remember, terminal velocity is constant velocity, where net force will be zero or net acceleration will be zero. So it is the constant velocity with which body will ascend or descend in viscous medium. So If you equate net force to be zero, so total upward force and total downward force must be equal. So you'll get terminal velocity is equals to m times g 1 minus sigma divided by 6 pi eta r. It may be also written as 2r square 9 times eta sigma minus rho times gravity. So first expression is based on mass of body and second expression is based on radius of that particular body. There will be question on combination of raindrop. So V2 will be equals to n to the power 2 by 3 times of V1. Let's say we have n number of initial raindrop falling downward at some velocity V1. If they combine to form single drop having velocity V2. So what will be relation between V1 and V2? So this will be relation. Saifullah, any doubt?
So say it again.
If you have n number of small drops falling at terminal velocity V1, if they recombine to form single drop, so what will be new terminal velocity of after combination? So this will be relation. Is it clear?
Yes, sir.
Next is equation of continuity. Let's say this is a tube having area of cross section A1 and A2. Liquid is flowing at this instant having velocity V1, this instant having velocity V2. If liquid is non-viscous, incompressible, so you'll say according to conservation of matter, mass of liquid entering first end per unit time should be equals to mass of liquid ejecting at the other end per unit time. So on comparing, you will get A1 V1 equals to A2 V2 and which is also equals to Q, which is nothing but rate of flow of liquid. So we may define this equation of continuity as for non-viscous incompressible liquid flowing in tube, the rate of flow of liquid. Rate of flow of liquid means volume of liquid flowing per unit time. Volume of liquid flowing per unit time at any instant will be constant or it will be same. So from this part, product of area and velocity of liquid will be constant. So we may define area and velocity is inversely proportional to each other. So if area is small, velocity will be large. If area is large, velocity will be small, and vice versa. Saifullah, is it clear?
Yes.
Safila, just see chat box. I have sent you a question paper. Two different question paper. First one is related to whole syllabus of second term, and second one is based on just solid and fluid. Did you receive, Safila?
Yes, I received.
Okay. In first paper, just see question number 14. Or part.
I cannot see the first paper, sir. I don't have PDF in this computer. I have to check in my other computer.
I've sent you in chat box two paper.
No, I downloaded it, but I
Yes.
cannot open it since I don't have PowerPoint in this computer.
Okay.
So I will be seeing it later after the class.
Okay. Question is, let me just define you. What do you mean by the term coefficient of viscosity? State Stokes law, define terminal velocity, and find expression of terminal velocity. Okay. Next question is, what do you mean by equation of continuity? State and derive its expression. So we may define equation of continuity like this, and expression of it, equation of continuity will be this. Okay.
Yes, sir.
Next, and the most important part of this chapter is Bernoulli's principle. Suppose you have a tube like this. Whose end is at different height. Let's say area of cross section is this. Velocity of layer of liquid at this end is V1, and velocity of layer of liquid at this end is B2, area of cross section is A2. Let's say liquid is non-viscous, incompressible, gravity is constant, and energy is conserved. So according to Bernoulli's principle, sum of pressure, kinetic energy per unit volume, potential energy per unit volume at any instant will be constant. Let's say this is H1 and this is H2. Let me define you and prove this particular statement. There is some assumption or limitation. You will say, for non-viscous, incompressible liquid flowing in a tube of varying cross section and at different height. The sum of pressure, kinetic energy per unit volume, and potential energy per unit volume at any instant is constant. So we have some limitation of this part, or you'll say assumption. Liquid is incompressible, non-viscous, gravity is constant, and energy is conserved. Safullah, is it clear?
Yes, sir.
So how to prove this statement? You will say we must need any external agency to flow liquid from lower end to some higher end.
What is E?
Is energy. So let's say pressure P1 at this end is applied and at this end P2. This pressure difference will do some work to move liquid from lower end to higher end. So first we may define work done due to pressure difference. Work done is equals to P1 minus P2 multiplied by volume. Do you know work energy theorem? Saifullah,
Yes, sir.
do you know work energy theorem?
Yes, sir.
Just explain.
It states that energy can be transferred from one form to another.
It is conservation of energy, not work energy theorem. According to work energy theorem, Work done by any external agency or non-conservative force will equals to change in kinetic energy and change in potential energy. So according to work energy theorem, in this part, work is being done by an external agency in case of pressure difference. So work done equals to change in kinetic energy and change in potential energy as well. Now substitute work done as P1 minus P2 multiplied by volume. Kinetic energy is half m V2 square minus V1 square. Potential energy is mg H2 minus H1. Move this volume to right side. So we'll get P1 minus P2 is equals to half mass divided by volume times V2 square minus V1 square plus mass times volume gravity H2 minus H1. Is it clear?
Yes, sir.
This is nothing but density of liquid. So you may write half rho velocity square minus half rho v1 square plus rho g h2 minus rho g h1. Now move same term or having same script to one side and other to other sides. That is P1 half rho V1 square and rho G H1 equals to P2 half rho V2 square plus rho G H2. So you can call sum of pressure, kinetic energy per unit volume, potential energy per unit volume at any instant for the flow of liquid is constant. This is pressure, this is kinetic energy per unit volume, and this is potential energy per unit volume. You may write this expression as pressure divided by rho times gravity plus velocity squared by 2 times of gravity plus h is equals to constant, which is nothing but this is called pressure head, this is called velocity head, and this is called gravitational head or gravity head. Pressure head, velocity head, and gravitational head or gravity head. Saifullah, any doubt?
No, sir.
Done.
1 minute, sir. Yes, sir, done.
Next, you'll be asked to define Stokes Law. Suppose you have tank. Let's say this is closed tank in which liquid is filled up to this level. So let's say this is one of the cross-section area. And this is other cross-section area. Like this. This is height of level of liquid in tank. This is a height up at which a hole is cut out. And this is position of hole from bottom part. Let's say pressure at this point is P naught, that is atmospheric pressure, and velocity at this end is approx 0. Velocity of ejecting liquid at this end is VE, and pressure at this end is also P naught. So if you apply Bernoulli's principle in this part, according to Bernoulli's principle, P1 plus half rho V1 square plus rho G H1, P2 plus half rho V2 square rho G H2. P1 is P naught. This is 0. Rho G H. This is P naught. Half rho V square and rho G capital H minus small h. This part and this part will cancel out. Move this term to left side. So you'll get rho GH minus rho GH minus minus plus rho G small h is equals to half rho VE square. This part and this part will cancel out. So on solving, you will get velocity of E flux is equals to 2GH. This part. So this is called velocity of efflux, which is also called Stokes law. So we may define Stokes law as, for open tank, if hole is at height or at depth h, so velocity will be this. It means it behaves as if a body is freely falling under the effect of gravity. Is it clear?
Sir, can you explain again?
Suppose you have a ball initially at this point having initial velocity 0. So let's say at height h, if you have to calculate final velocity, so according to expression or using third equation of motion, velocity will be equals to root under 2gh, which is same as in this case. So we may call liquid falling through height h will attain same velocity as if a freely falling body under the effect of gravity. Hence we can say liquid in a tank falling through height h will attain same velocity.
Yes, sir. So this is also called equation of efflux.
Yeah. Done.
Yes, sir, done.
So this is all about entire fluid. Okay. Yes, that's it. So you'll be asked these different questions from this part. Okay, so let's stop here. I'm not well today. We'll continue in next class. Okay. The next
Yes,
class
sir.
just revise waves and oscillation. That how much I have taught you. The question will be from that part also. Oh, okay.
So it's going to be a pen paper test or an oral test?
Pen paper test
Okay, sir.
based on perfect CBSE syllabus.